had to define a couple of parameters and had to mess around a little bit with the sensor calibration. But ultimately, the code is quite straightforward. If the sensor value reaches above 100, a few things are going to happen. I've set all the buzzer tones to be at 300, just something that I noticed that was quite consistent with the classical Geiger counter. The LED strip lights in blue, and during that time, the buzzer will release a sound with a randomized range value of seconds. It's quite short, because that's kind of the sound effect of a classical Geiger counter. Then the LED will flash dark, as in it's not going to be lit up. And again, randomized duration of the buzzer. The LED will then light in yellow, random duration of the buzzer, over a range of limits that I tested that sounded very good. And finally back into black again, i.e. no color. Are there better ways of coding this? Probably. But I was really happy that I was able to do this myself. Of course, ultimately, else statement. If the sensor value is not above 100, it just remains dark. I wish you the best of luck in your own projects. Hello. There we go. All right, that's done. Hi, Blaze. Welcome in. Hi, Harry, Herder, Steve, Corby. How are you keeping? Hope you guys are having a wonderful, what day is it? I'm trying to remember. It's Sunday now, yes? I messaged you back, Blaze, by the way. Hi, Dr. Ambassador Tofu. Hello. How are you doing? How are you keeping? You cannot be stopped. A 300 stream streak. Let's go. Let's freaking go. Something, something, touch grass. Something, something, something. I've started reading Hegel's Phenomenology of Spirit. Pray for me. Jesus, I couldn't even say that word, Corby. What's it about? The email. You sent me an email? Am I correct in saying I got an email this morning? I messaged back almost immediately. I'm doing well on this fine Sunday. I decided to switch up my streaming topic today. We're going to do proper physics today. We haven't done proper physics in a while. And so I think that's a great theme. We're going to do physics today. It'd be nice to switch things up. Hello, Spideycraft, welcome in. Happy Sunday. Medjay, 260 stream streak. Welcome in, welcome in. I hope you're feeling a bit better today. Hello, Scorpio, welcome. I'm here for the greatness. Oh, well, we all know that Tofu's great. Tofu the Great, as they call me, somewhere in some parallel universe. Parallel over parallel universe. Let me just check that I've posted everything. Yes, I have. Excellent. Excellent stuff. Excellent stuff. Today we're actually doing physics. We're switching up because I keep doing projects. And I love doing projects. Projects are a lot of fun, I will admit. They're good crack. They're good fun indeed. But also, sometimes you need a break from a project. I will set up the Demon Core though, just for the day. So it can go off as free will. Oh.
No, thank you. We don't want any more visitors, well-wishers, or distant relations.
And what about very old friends?
Test if it works. it works. Yeah. Hi, Lana. 32 months. Let's go. In about a month's time, we're going to see each other. Welcome in, Lana. I hope you're keeping well. Thank you so much for the sub. You're very, very good. The core that houses Maxwell's demon. Oh, stop. That demon pisses me off to no end. Goddamn demon. Alright, I'll exit out this. Printing? Is it printing? Let me double check that my print went through. Yeah, it's excellent. I just want to say that you're an amazing, fantastic teacher. Oh, I'm glad to hear that, Spideycraft. I'm glad. I'm glad that, you know, YouTube is helping some people. I think YouTube is great. Even for my Twitch followers, I think YouTube is a great archive for a lot of things. So yeah, I'm glad to hear that it's at least helping someone. At least someone in the universe. For now, it will be the chemistry of super strong coffee for me. Absolutely. Cheers for the coffee. Cheers. All hail coffee. Good afternoon, Jimmy. Did you switch your team fast enough? What time is kickoff today, actually? Might not be able to keep an eye on the game today. I'm praying for the biggest upset in history. I'm praying for the biggest upset ever. Yes, that is my hope. Wait, who have Italy played? Have Italy beaten everyone thus far? Actually, wait. Oh, we played them. Oh, yeah, I forgot. Oh, yeah, never mind. Yeah. I forgot about the fact that we played them already. That was a pearl-clutching game. That was a little uncomfortable. I would like to say that was too close for comfort. Although the Scotland game was quite funny, just because of the downpour of all places. Or will it be sweet? Curling is the one, again, I'm so sorry. I'm only emphasizing it because it's a meme right now. It's that one, right? That's curling. Hi, Lind. Привет. Welcome in. That's the one, yeah, okay. There's actually, I told you about it, there's a really cool physics behind it as to how curling works and what they do with the brooms in front of it and everything. It's really interesting. There's a few YouTube videos on it. I think the social media physicist who talked about it is called Blitz PhD, I think is his name. I really like him. I think he explains a lot of the things. He also just confronts a lot of conspiracy theories. And although I'm a person who kind of stays away from that, I shy away from videos like that. I'm just glad that there are people out there who do those videos. I know that it might seem mean and aggressive, but also, you know, in the day and age of misinformation out there, I think more than ever those videos are needed. Just because I don't do them doesn't mean they're not important. I just don't have, I don't have the heart to go through the hate. Quite difficult to live through that. With the stones and the brooms. I actually realized that I left my first year textbook at work, so I don't have a book to reference from. Obviously, I'll wing it, but most of the stuff that I want to do is I want to come up with some motions in one direction problems. So if anyone hands their homework, you're more than welcome to send it to me. Oh, Blaze, I'm so sorry that it happened. I really want to advertise that be careful about me messaging anyone. I would never ask for money from anyone. I never do. Be careful of that. I will never DM anyone. The only thing I could DM people for is... There's two reasons. If you submitted a lab rat pass, I will DM you for your address. But the other thing is for a podcast invitation. So do be careful. Just watching you because I love physics, not a student, just out of curiosity. That's really good and a great username, State of Mind. It's a really great state of mind to have. YouTube is amazing. You learn so many things on YouTube. Like, if you have a problem, chances are someone made a YouTube tutorial about it. Chances are someone made a YouTube tutorial about it. If you're ever stuck in your house, you will probably find it. I came for the code. We're not coding today. Today we're taking a little break from coding Clumsy Cars. Today, instead of... so, what's in our project? Okay, so our next step in our project is our PIR sensor and our infrared sensor work really, really well. Sorry for all the wires. But the problem is that the two OLED screens are on the same address. So our next step is I'm going to take out one of these guys and I'm going to short a connection and desolder a connection. So that's the next step for our project. Yeah. But we'll take a break of that today, just so that we can do science. Today we're doing equations of motion, which will be really nice. We can maybe ignore the 3D printer. She's going to be busy in the background doing work, printing some stuff for me. But yeah, that's going to be the plan today. And of course, as always, we will take over the world! That never stops. Taking over the world never stops. Hi, New Way! Welcome in! How are you keeping?
Dude, Rain, what do you want to do tonight?
The same
You
thing we
activated
do
the demon
every
core,
night,
Medjay.
Pinky. Try to take over the world.
Careful now with that stuff. Taking over the world is a... Ah! is a nasty business. Hi, Bubster. Sweden has won! Let's go! Are we celebrating? Are we happy that Sweden won? Yeah, Tiny Tofu Rad is more important than ever before now. I have one textbook for reference. I do appreciate these textbooks, but I don't think I have any motion in a straight line. Oh yeah, there's supplementary problems at the back with no solution, so maybe that's something that we could have fun with. Well, fun is a stretch of a word, but we can solve a couple of stuff. Motion in a vertical plane. What does that mean? That's projectile motion, I think. Yeah, we won't even get to that. We'll just do simple problems. I don't have solutions here, but it might be a nice thing to try and solve. Have to think on our feet. Command and Herder is giving a Tofu Laboratory mug into the Twitch chat. If you want to enter, quick, exclamation mark enter, and you guys could have a standard chance of winning a mug. A Tofu Laboratory mug. Ah, that is so kind of you, Herder. You're so good. Thank you. Too kind, too kind. Thank you so much. Hi, Father Dougal. Welcome in. So, yes, it is time for you all to come out of lurk for the chance of winning an amazing mug. Father Dougal, congratulations on winning the gift. Thank you, Herder. You're very, very good. I hope you enjoy it. A great laboratory mug for you. My 3D printer is very loud. I didn't check if... I hope I did it right. I did something new. Yeah, anyways, it's fine. It's fine. With the giveaway completed. I know we're just starting stream, but fuck it. Nothing wrong with starting the education early. Let's move chat a bit though. You guys are a bit bold. You guys can be a bit bold. So we're just gonna move you in the corner, into the bad corner. Chat, you're in the bold corner now. There we go. Bit lopsided. Maybe I'll put you... okay, maybe we'll just move chat away completely. Chat, you're bold. We're removing chat now. Hi, Pega, welcome in. Hi, Phoenix. So again, I know yesterday I said that we were going to do the project. We're going to continue with our coding and our Arduinos and the OLEDs and sorting out the address thing. I'm going to take a little break because we've been doing a lot of projects and haven't done much physics lately. So today we're doing equations of motion and we're going to be solving problems in one direction. So a couple of things that I want to talk about first before we get started, just a few topics to hit on. Number one is to talk about a very simple concept of vectors and scalars. So in the English language, we say something like, I'm traveling 20 kilometers per hour, that is my speed. But if you know you're traveling north or you know you're traveling a certain direction, that will be a vector. And instead of saying speed, we will say velocity. Most of the time, I will be interchanging between speed and velocity in a lot of my units, but always assume when I say velocity, we mean speed. Sometimes I'll give a direction, sometimes I won't. It doesn't matter. All we just need to know is that we know that there is a direction. We might not mention it though. So V is going to stand for velocity. Otherwise known as speed, okay? Now, specifically, I'm actually going to use this notation for a very, very specific type of speed. I'm going to be using it for final speed, final velocity. Hi, Wombat Hole! 10 stream streak, let's go! We're going to be using it for final velocity. Because in our story, we're going to have a starting velocity, mid velocity maybe, average velocity, and then there's a final story velocity as well. Another thing that I'm going to use a symbol for is the letter U, because it looks really close to B. And this one is also going to be velocity. But this one is going to be initial velocity. So sometimes I'm going to tell you a story. I'm going to say, wow, this car starts at 20 kilometers per hour and ends with 60 kilometers per hour. So that would mean U is 20 and V is 60 kilometers per hour. It's the same thing. Everything is the same. It's just another unit that we're going to be using. Another letter that we're going to be using, just to determine it differently. Some scientists or some of your textbooks will use something like VI for initial, VF for final, or V1 for starting story, or V2 for final story. It doesn't matter. All is the same. It's just what it is. I prefer not to. I don't think the subscript is nicer because when you start dealing with a little bit more forces, momentum, all of that, you're going to have a lot of subscripts because you're going to have objects, object 1, object 2. And so you'll have the velocity of object 1 initial, the velocity of object 2 final. You're going to have a lot of subscripts. So just to remove them, I prefer to use V and U. It's Nathan. Nathan keeps banning all the doors. Popping the demon core. Okay. Another classical thing that we're going to be talking about is time. Time. Lowercase t. So I would say something like a car is traveling at 20 kilometers per hour for 3 minutes. Our time is 3 minutes. The SI unit for it is seconds. I'll cover SI units in a second. So classical time conversations. Or is Bambi thumping violently? Oh, Jesus, if she's thumping that bad. Oh. Shouldn't have been me. Listen, Pega, Valentine's Day just happened. What the heck? My God, will you stop going radioactive? Now, similar to velocity, distance also can have a direction, and something that we say is displacement. Now, some textbooks will use the letter D for distance, but if you're specifically saying displacement, we actually use the letter S for displacement to differentiate between a vector and a scalar value of it. But again, most of the time we know what we're talking about. Most of these problems are arbitrary, and it doesn't matter what notation you use. We generally stick to S displacement. It's a bit weird because we do use the letter D sometimes for distance. We even use the letter R sometimes for distance, usually coming from radius, and there's a history behind it usually. But just bear in mind, it could be D sometimes, it could be R, but from here on in these problems, I'll be using the letter S. I really apologize for the Demon Core. I think I'm standing too close to it. And just popping. I'm just making the Demon Core activate non-stop. I'm too close to it. Okay, VUTS, and the last one we're going to talk about, hello hacks, welcome in, is G, or A, sorry. Which is acceleration. Acceleration. I say acceleration, yeah. So acceleration is very, very interesting because in physics, acceleration means many things. It could be you're speeding up your car. It could be that you're slowing down the car. But another thing about acceleration is you're turning the wheel. So the joke is there's a meme of how there's a brake, an accelerator, and a wheel in a car. Most people see those three things as different objects, but a physicist will see it as an accelerator, accelerator. They'll see them as the same things. That's where this comes from. So acceleration means you're changing direction, you're changing speed, either in the positive direction or the minus. Just bear in mind, sometimes physicists will say deceleration, which means it's acceleration with a negative sign. Acceleration with a negative sign. So if I say I'm decelerating by 2 meters per second squared, my acceleration is minus 2 meters per second squared. What about clutch? Some of us don't drive with a clutch. Yeah, I still use that sometimes. It's in the textbooks. I'll avoid it just for the sake of avoiding it. But it is something that's in textbooks. It's not meant to be used. Unfortunately, that word is scientific, and that word instead gets used negatively. I don't know if most countries do, but in Ireland it's particularly bad, so I usually avoid it. All right, so a couple of things to cover. Minus sign. So I said that if you're decelerating, if you're slowing down, you have minus acceleration. But you could also have minus speed. If I say I'm traveling at 2 meters per second this direction, and suddenly the car decides to, you know what, reverse in 4 meters per second squared in the 4 meters per second in the opposite direction, it's going in this direction. We put a minus sign in front of it because it's going backwards. Herder, you're giving so many gift subs these days. You're very kind. Rogue Jelly, enjoy the wonderful emotes by Jay. Welcome in, Viad. Okay. So we have velocity. Okay, units. Here we go. We have units. So something that we're going to convert most of the time is into SI units. Sometimes we won't if we don't need to, but generally speaking, most of the time we are going to convert to SI units. So remember your SI. There's actually only 3 that you need to remember out of the 7 base units. Meters for distance, second for time, I was thinking kilogram, but yeah, we're not even, because we're dealing with motion in one direction and not what caused the motion, i.e. force. We actually don't even need to take mass into consideration. So it's just those two. So this is meters per second. This guy is meters per second. This guy is second. This guy is meter. And this guy is meter per second squared. A fun exercise when we're going to be solving these problems is that we're going to keep track of units, and we can test our answer really quickly by making sure that our units are correct. Again, did Herder give you another gift sub again? Herder's very, very good. Very, very kind, giving so many gift subs to everyone. All right, I think we've covered the introduction basis for everyone. These are the 5 aspects that we're going to be dealing with, and we can solve pretty much any problem. So I'm going to make up a problem first. Just to get us started. Oh, you know what? Before we start that, let's talk about a couple of equations. One of the equations we'll talk about is, what is speed? Speed, v, or u, it doesn't matter, is simply distance over time. And if you ever forget, you're like, oh, my brain is slow, what is going on with me today? I always remember the speed limits in the road. In Ireland, we use kilometers per hour. I always remember distance over time. That's the way I used to remember when I was very, very young, and now it's way, yeah, you don't even have to think about it. I have played Kerbal Space Program before a few times. I didn't get into it too much. I will say that it might not be the game's fault I didn't get into it. I unfortunately, there was a lot of backseating during that game. And I was on the tutorial. So people were like min-maxing and telling me how to do things when I was literally overwhelmed by the tutorial. Oh, like where the engine was. Do you know what I mean? So so for me it was a bit too overwhelming and it turned me off from the game. So yeah, it was unfortunate, it was. Usually my community, we have strict rules about backseating anyway. But unfortunately, or fortunately, look, it was very kind, I got raided. And it was a big raid and there was loads of new people, and I know people didn't mean it negatively. I know that. I know they didn't come in with negative attitudes. It's just, it was a lot of min-maxing. And I was just like, dude, I don't even know. I just need to find where the engine is. Please stop. Alright, so speed is equal to distance over time. Kind of makes sense. Hello, Felice, welcome in. So we have distance over time. Next thing that we're going to talk about is what acceleration is. What is acceleration? It's, well, you slowing down, right? So if you wanted to know what your acceleration is, let's think about what it is. It's meters per second squared. It's how fast your speed is changing. Think about what I just said. How fast your speed is changing. Speed is changing. Change, or rate, that's another word we use, means per time. So speed per unit time, meters per second per second. That's where we get this. Meters per second squared. So it'll be our final speed minus our initial speed, the changes of our story, that's their speeds, all over time. Meters per second per second. So our units are correct. We can rearrange this equation. And this is the classical first linear motion equation that everyone knows about. Hi, Car. Speed is the exact same thing as velocity, almost. Velocity just has direction. But in physics, in almost all our stories, we know what the direction is. We might not say it, but we assume we know it. We'll just say velocity no matter what, even if we sometimes don't give direction. So technically, the unit for speed is meters per second. And then if I said the car is traveling 10 meters per second north, that would be a velocity. Now, the next two equations, we won't derive them today. That's another video I already have actually uploaded if you're ever interested in. But just to cover a few things, there's two other equations of motion. For today, I'll just say, trust me, this is true, is S is equal to UT plus a half AT squared. Okay? Jesus, I made it worse. I'm so sorry. Oh, for fuck's sake, the demon core is just after, yeah. For today, I'm just going to ask you to trust me. I might record and upload a video on it again one more time. I have a few shorts on this anyway. But this is another equation of motion. The distance is equal to UT, the initial speed times the time, plus half AT squared. Obviously, if the object is accelerating, it's going to cover more distance. So that's what that part is really, really important about. Not the demon core. I know. I'm sorry. Let's put it back there. All good. Nobody panic. Demon core is fine. And the last equation, again, just trust me for today, is V squared is equal to U squared plus 2AS. You can actually derive all of these derivations either using algebra or graphically or calculus. So I've done all three of them before if you're interested in doing so. Okay, so now that we've covered those things, let's solve a couple of problems. Oh, I've never seen Speed 2. I do. I have loads of shorts on it, Bobster. I never uploaded a proper YouTube full video. That's why I was thinking maybe I'll do another recording of that. Okay. I did it a long time ago. It was when I first kind of started doing a lot of education stuff. One of the first things I used to teach. Right, let's take a car. A car full of lab rats. You can see it's a rat car. Looks like whiskers, okay? And it's driving in this direction. That's the tail. It's driving in this direction. I hope that's pretty obvious. And we reach a stoplight, okay? So, this light suddenly turns red. I have a red marker. Okay, actually I think red is at the bottom, isn't it? I don't remember my lights. Is it green, yellow, red, or red, yellow, green? I don't remember. A Ratmobile, there we go, a Ratmobile. So the minute the rat car notices that the light turns red. Hi, they DVX, welcome in. No, this is live, all of this is live. What does U mean? U means initial speed. Initial speed. The starting velocity. Hi, good Sunday. Hi, Manan. Welcome in. Welcome in. Woo! Oh, for feck's sakes. My demon core keeps getting activated. I really need to stop. So the minute the Ratmobile notices that there's a red light, the distance between these two guys is 22 meters. Okay? The car is initially driving at 30 kilometers per hour. Calculate how long it will take for the car to stop and what its deceleration is. Okay? So let's think about it. I always teach my students this. With all of these equations and motions and projectiles and all of this, there's always, okay, always is a stretch, but generally speaking, I should really stop activating the Demon Core. There's always 3 pieces of information hidden. So our initial speed is u. Our displacement is 22 meters. And there's another third hidden information in here. V. If the car is stopping at the end of the story, its final speed has to be 0. So we know all those stories. Now, a quick thing that we need to do is convert 30 kilometers per hour into meters per second. Let's do that. So 300 divided by 36. 300? Yeah, 300 divided by 36. Hopefully. It's red, yellow, green from the top. Okay, so I was right. Okay, cool. So it's 300 divided by 36. 8.3. Okay. That's not what I calculated in my head. I'm not good at mental maths. Okay, so it's traveling at 8.33. Can you explain free fall? Yes, we'll do free fall in a little while. This is a pure crash course. We're starting from the beginning. I'll get to free fall today. Hi, Mord. Welcome in. Welcome in. Yeah, reoccurring. So if I wanted to be pedantic, I'd put a little dot on top. Okay. So, 8.33 meters per second. Sorry, my Demon Core keeps getting activated. Nathan is banging all the doors in the house. So, it doesn't activate because of my voice. It activates due to vibrations. It's very sensitive to vibrations. Just to know about the bit more accurate to the Demon Core. Anyways, 22 meters, 0. This is the same thing as 0 meters per second squared. Okay. So we know U, S, and V, and we're looking for 2 things. T and A. So let's look at our equations of motion that we just derived earlier. We have V is equal to U plus AT, S is equal to UT plus a half AT squared, and V squared is equal to U squared plus 2AS. Remember your... What's the term? Remember your... algebraic solving skills. You can only solve one equation when there is only one unknown. So, we're looking for A and T. There's 2 unknowns here. We can't use that. We're looking for A and T. We can't use that. We don't have A or we don't have T. However, look at this guy. We have V, we have U, and we have S. So we can solve the equation by using this third equation. Remember your what's it called? I couldn't solve one question. Can I write the question down here? I'll try and get some questions done towards the end, perhaps. Sorry, I have a minor lesson plan roughly speculated in my head. I need to get through that first. Trying to get some crash course done first. That's okay. That's too kind of you, Furry Knight. Fury Knight even. Not Furry Knight, that's rude. Will this be on the test? Yes. Okay, you know what, Barg? I will solve that for you. That's a nice problem. After this problem, I will solve that problem for you. I'll show you the solution for that. I will help. I don't usually help people with their homework, but I'm going to do it today. Okay, so V squared is equal to U squared plus 2AS. Let me change marker so we don't get too confused. Rearrange the equation to find A on its own. So U is being added here. It's going to be subtracted over here. Two and S are being multiplied. So to bring them across, we multiply them, or we divide them over everything else here. So that's 2S. There we go. So V squared in our thing is 0. That's 0 to be squared. Minus 8.3 all to be squared, all multiplied by 2 times 22. Our acceleration is, and you might be scared, you might be a bit alarmed and be like, wait, I know what it's going to be. That's going to be weird. And I'm going to say, no, it's not going to be weird. It's going to be absolutely right. It's 1.57 meters per second squared. What did I forget? There's an important thing I didn't put in there. The minus sign, exactly. It's decelerating, so it makes sense that the minus sign is there. Everything works out well. Everything's correct. So it's minus 1.57 meters per second squared. So our acceleration is minus 1.57 meters per second squared. Okay. So, I'm just running out of space. I always complain that my whiteboard is too big, but honestly, most of the time, I run out of space too easily. Maybe I write too big, but I feel like especially if any of you are on your tablets, you're screwed. You need to see a lot here, I think. Although I could zoom in the camera, that could be another option. Bring it closer. Yeah. Bring it a bit closer. That's not bad. Yeah, we could do this. All right. Move the mic a bit. Nice. Okay. Now we have so many pieces of information. We have V, we have U, we have A, we have S. We're looking for T. As you can see, we can use either or equation, but it's going to be so much handier to use that first equation. Okay, we need to rearrange it. We want T on its own. U is being added here, so it's going to be subtracted on this side. A is being multiplied. We're going to bring it across. There we go. Let's substitute everything. V, our final speed, is 0. Our U initial speed is 8.33. And our acceleration that we calculated was 1.57. Yeah, 1.57 meters per second squared. And that's really important, because the two minuses above and below will subtract, and you will get a positive answer in time. Generally speaking, you can... just be careful about what I say here. Take it with a grain of salt. But generally speaking, you can never get a minus sign for time. You can have minus displacement. You can have minus velocity. You can have minus acceleration. But never time. Time cannot be in the minus. 5.3 seconds. So here we go. That's kind of cool. We knew the car was starting at 30 kilometers per hour in our story. It traveled 22 meters before it came to a full stop. And so we could calculate so many things out of it. We knew what its final velocity was. We could calculate the time it took for that to happen. And its rate of deceleration as well. Really cool pieces of information were found out of this. Now, I'm doing something unusual. Someone asked for help for their homework. So I'm going to solve someone's homework here real quick. And like I mentioned, we'll do some free fall questions as well. Give it a second to dry. On a rainy Sunday morning. This was actually sponsored. It was my first ever sponsorship, Phoenix. It's Max Tech Global. They sent it to me. I did a whole sponsorship post for them a while ago. Max Tech. I think this is how I spell it. About this time last year, I did my first ever sponsorship. Just waiting for the board to dry a little bit. Thank you, Zier. We maybe should make a command, exclamation mark, whiteboard. Did they send you anything else? A couple of markers as well, but that's it. Yeah. But I'm really lucky, like I do get sent a few things. There's going to be a new sponsorship uploaded now as well. Yeah, I'm kind of cool that I've gotten to that stage on social media and stuff, that I could get stuff for free. The problem is I don't think I'm going to be accepting anything for free anymore. After I realized how much tax I have to pay on it. I don't know if all nations are like that. In Ireland and the UK, if you're an influencer, I say that in comments because I don't really think I'm technically what an influencer is meant to be. If you're an influencer and you get free stuff, you have to pay tax on it. And so it's quite a lot of tax on me. So unless it's something I actually want and need and I'm interested in, like this whiteboard, then I won't be taking stuff in. If you ever see me do a sponsorship, know that I'm actually using that thing. It's something that I was actually interested in. All right. So, someone in the chat asked, a bus decreases its velocity. So we have a bus now. Very weird looking bus. I think we have not the right movie. The wheels on the bus go up and down, and it decreases its speed from 80 kilometers. So the initial story is 80 kilometers per hour to its final velocity of 60 kilometers per hour. In a time of 5 seconds. Okay. And the question asked, what is its acceleration? It's a very nice, handy question. I like it because the final speed isn't 0. Most of these questions are always going to have final or initial speed being equal to 0. And it's like almost cheating, but it's nice to know that we can do it. So, a couple of stuff first. It didn't say that we need acceleration in SI, but I always do SI. So that's going to be 80,000 divided by 3,600. And this guy is going to be 60,000 divided by 3,600. There's 3,600 seconds in an hour, in case anyone's wondering what I'm doing there. Ah, welcome from Algeria. So 80,000 or 800 divided by 36 is equal to 22.2. I don't know why I don't remember this. This is such a classical question. 22.2 meters per second. And 600 divided by 36. Is that an even number? No, it's not. It's 16.6 meters per second. Okay. So, as always, especially if you're doing this in an exam and in a test, hi Tails, I always recommend just writing out these equations. Listing what you know, listing what you don't know. And it's very clear once you tick everything off. We can tick off here, we have V, we have U, we have T, and we're looking for A, acceleration. So it's excellent. We can use our first equation. V is equal to U plus AT. U is being added on this side. To bring it across, it's going to be multiplied. Oh, sorry, subtracted, apologies. And then T is being multiplied by A, so it's going to be divided when we bring it across. Let's sub in all our numbers. V is equal to 16.6 minus 22.2, all divided by 5 seconds. So our acceleration, and again, don't panic that it's a minus sign, it's good. Minus signs are okay in physics. 16.6 minus 22.2 divided by 5, and we get minus 1.12 meters per second squared. Distance over time, or speed over time, meters per second. Our unit is correct. We get meters per second squared. Excellent. And the minus sign means it's decelerating. It's slowing down. So all is good, and we know we solved this problem correctly. Exactly, Henri, because it's deceleration. And there we go. We solved the bus problem. Now, someone asked for a free fall question, and that's a great question. So hopefully, Bar, I helped you out with your homework, but I also hope that, you know, you were able to solve it by yourself. I'm sure you were, of course. Hi, Lizeth. Hope you're keeping well. Our next question that I'm going to propose to you is free fall. I'm going to do some free fall. How do you solve it without a calculator? Okay, well...
Boots and your motorcycle.
Hi, Spooky. So if you need to solve it roughly in your head, it's usually long division. God, I haven't done long division in ages. But I would cancel these zeros, okay? So that would be 800 divided by 36. Oh my God, I don't know how to do long division. I haven't done it since primary school. Wait, okay, let me practice my long division. So if it's 36 divided by 800, so do I start forwards or backwards? The forwards or backwards I start with long division. I think it's this way. So 36. Am I doing that right? I wonder. A brief learning intermission. Yeah. No, it's good to practice. You can do a few mental things, right? Let me think about this. It's roughly 40. 40 goes into 80. Yeah, this is how I would do it if I were to do an estimate. So it's 4 away from 40. It goes in there 20 times. 36 is smaller than 40, so it's higher than 20. So it'll be just above 20 meters per second. Then 4 would go into the next set of zeros. How many times? Tofu, Gen Z will do some weird stuff. Do they? How do Gen Z do long division? Is there any... Okay, now I'm curious. How do... Okay. So 36 multiplied by 2 is 72, right? So 720. It goes 720 times. So it goes 2 times 720, well, 20 times. You're left over with 80. Is that right? 36 goes in twice, so 72, right? Carry 8. Oh, carry 8, exactly. So carry 8 over. So that goes 2 times, carry 8 over. Or is it here I used to do it? 36 goes into 80. How many times? 2 times. Ah, there we go. That's how it works. So it goes into 80.0 you keep carrying the 8 over. You'll always have 8 replaced and it'll go 2, 2, 2, 2. It'll keep going on infinity. You keep dividing it, and that's why you have 22. There we go. 22.2 meters per second. Oh yeah! I remember long division now. Oh shit, am I muted? No, okay. Maybe my mic was cutting out earlier. Hi, Lady Vampire. Welcome in. Oh, that was actually fun. I forgot how to do long division. It's great to do it again after so long. Happy Sunday, everyone. Welcome in. So yeah, that's why it's infinite, because you'll keep bringing the 8 over, and it'll always be into 80, into 80, into 80. It does bring back, yeah, like I haven't done it since primary school, so it was great to do it again after so long. So that's how you would solve it if you had no calculator. You just do long division way. But also, unless the exam question didn't say to convert to SI, then it's actually kind of straightforward. Let's look at the question again. Oh, I took it down. Never mind. It was 80 minus 60, which is 20 kilometers per hour. Over 5, 20 divided by 5, 4 kilometers per hour, basically, you end up getting. So it's not too terrible as long as you don't have to convert anything. There we go. Can you explain pulley problems? I'm not going to do it. I'm not going to do pulley problems today, but I have a few pulley problems on my YouTubes if you're interested. Hi, Michael. Welcome in, Raiders. I have a raid thing. I'll show you. Watch this. Chat, defend the stream.
Red alert. All hands stand to battle stations. Laying an intercept course on the Romulan ship.
Shields up, load all torpedo bays. Stand by phasers.
Warp factor 8. Engage.
That's true. 5 is in seconds. I forgot about that. Fair point. Then it's probably easier to do the long division like I showed there. Hello. Welcome in, Michael. How was your stream today? But we have no green swords. You don't trust us. Spooky. The day I give you a green sword is the day my stream is doomed. All morals are out the door of this channel. There we go. That'll be the day. You'll be working very hard for that day. Earl Grey hot. But I thought the Sith has red swords, does it? But that's okay, we're not Star Wars fans anyway. Star Trek for the win. Star Trek is so much superior than anything and everything else. Alright, will we do a freefall one? I like the freefall ones. So, an interesting problem, or an interesting concept that we need to talk about, I don't have pockets, I like walking around with my hands in my pocket, is the idea of dropping shit. Like this. So, my demon core went radioactive again. Oh, enjoy your lunch. Let's take an example. A terrible drawing, but this is meant to be Bambi, okay? So let's take my little cutie patootie Bambi, Bunzo. That's a rat. That's a bunny! What do you mean it's a rat? It has a little boopy tail. Look at the tail. It's a bunny. Bambi, her ears are too long to be fair, is sitting on a table. Let's take her on a table. Okay? And she is a brat. Bambi is an absolute brat. And one of the things that she hates on our couch or on our table is that we have controllers on it. PlayStation controller. Okay? and she knocks it. She brings her paw over. Here we go. Here's her paw. And she knocks the controller down. This is real science animation of the things that happen every evening in my house. Every goddamn evening. It's a battle. It's a battle in our house. Hacks. You're trying to get banned, aren't you? Yeah, it's wireless controllers, of course. Okay. And so she drops the controller. And I could say that the distance is half a meter. Or we'll say one is too easy. 1.2 meters. Okay? And yeah, that's all the information I'm going to give you. The distance from the couch is 1.2 meters. Solve for everything. Okay. Yikes. How do we do that? That's a bit odd. Hi, Minds. Welcome in. Excuse me, I'm burping. So, a couple of things that we can solve here is that our initial speed, right? Before Bambi knocks it off, or as she's knocking it off and before it falls, the initial speed of the controller, u, is equal to 0. Start of our story. It is equal to 0 meters per second. Excellent. Second thing is, as people pointed out, A is going to be equal to 9.81 meters per second squared. That is the acceleration due to gravity on the surface of the Earth. I also have a full YouTube video on this topic, on gravity and the concept of gravity and what I mean by acceleration due to gravity, why I say it the way I do. So obviously in your spare time, do check that out. But that is a very, very important aspect here. And what it means is if I drop anything, like this marker here, and I drop it and let it fall, it will speed up by 9.81 meters per second every second. So after 2 seconds, it's 18 points, and so on and so forth. 3 times, mental maths, roughly, okay, we'll do roughly 30 meters per second. After 4 seconds, roughly 40 meters per second. It will keep speeding up every second. Meters per second, the speed, every second, second squared. That's where that comes from. So there was 2 pieces of information hidden in this story. We can determine what the final velocity of the controller is, and if we wish, we could also determine the time it took for the controller to fall. So not a moon bunny. Logically, you know that it's going to be a tiny, tiny amount of time it's going to be in the air. And you might be thinking, well, how do you know, Tofu, it's going to be very, very small? Think about it. The acceleration says that every second it will speed up by 9.81 meters per second, which means that after 1 second, it would have traveled a distance of almost 10 meters. It's only falling 1.2 meters, so you know it's only going to be a fraction of a second that it's going to be falling. These are just little mental activities that you could do, and they're great to keep track of your maths. Just keep track of, oh, am I doing the correct thing? Well, most of us are never doing anything right. So it's just a nice little mental activity to do with your brain. So let's solve it. Let's go back to our equations of motion. We have v is equal to u plus at. We have u, a, and s. U, a, and s. Which equations could we use here? Do we have to follow the white rabbit? Not unless we want to uncover all the true aspects of our life, and if we do live in a matrix or not. Personally, I wouldn't take the pill. I would live in my delusion. But that's just me. Hi, Sama. Welcome in. Exactly. I really like what Zier said. You could use equation 2 or equation 3. But it'll actually be easier to use equation 3 because this is going to give us a quadratic and it's going to be a pain in the ass. One of the t's is going to be minus, which we can't get a minus t. So it's a pain in the ass to solve. So we're not going to touch that one with the 10th pull for now. Topher, are you not Irish today? Twitch tag is missing. I never removed my Irish tag. Actually, oh my god, all my tags are gone. What the hell? All my tags are gone. What happened? Physics is gone, everything is gone. I don't even remember. That's annoying. You're English now. That is annoying though. The tags never get removed. What is Twitch doing? God damn it. I had 10 tags. What were my usual tags? I don't remember. Science. I don't know. Oh, I can't type in ambassador. I'm not allowed to say that I'm an ambassador in a tag. Okay. Good day. Welcome in, Logic. How unusual. Well, look, it is what it is. It is what it is. Who needs tags anyway? You all know who I am. Wahahaha. A woman in red. There we go. Who took the tags? We'll fix them another day. But thanks for pointing out that the tags are gone, though. 0 meters per second, 9.81 meters per second. Anyways, so v squared is equal to u squared plus 2as. Do you see the green marker? Oh yeah, you guys can see the green marker. It's pretty good. So what we're looking for in this case is we're looking for v. So it's actually a really nice equation to rearrange for us. It's v, get rid of the squared, all under the square root, u squared plus 2as. Another easy thing, u is equal to 0, we can lob it off. We don't need to look at u anymore. That sounds mean. We don't need to look at u chat anymore. So that's just v is equal to the square root of 2 times the acceleration, 9.81, times the distance, 1. There we go. That's 2 times 9.81 by 1.2. That's equal to 23.5 meters per second. A fun little thing to check your units. That's meters per second squared multiplied by meters. So that's meters squared per second squared, square root that, meters per second. You're left with the velocity. Kind of nice little mental maths game always to do this. So we find out our final velocity is 23.5 meters per second. Jesus, that's really fast. That could hurt. Oh my god, you could kill someone with that. Bunzo's trying to kill us. I didn't square root it. That makes sense. That makes sense. I probably didn't square root it. .8 meters per second. There we go. Much better. Much better. That looks a bit more reasonable. It's always good to think about realistically about these questions. Like, that didn't seem right. Okay, so the velocity is 4.85 meters per second. Oh, is it 3.41? Did I do something wrong? My calculator wrong. Brackets. 2 multiplied by. I'm just going to put everything in brackets just to make sure I didn't make a mistake. 4.2. I got 4.85. Not 3.41. Oh well. We'll keep it with this. It doesn't matter. Ultimately, if I did something wrong in the calculation, it's fine. Okay. So that's the final velocity. Sorry, let me change that. .85 meters. The last one is t. We're looking for t, and I know it's going to be so nice and handy to use the first equation. V is equal to u t. That's V minus U over A is equal to T. Hopefully we're kind of getting practice with these substitutions. So you trust me why I'm putting these in. 4.85 minus 0 all over the acceleration, which is 9.81. The time is equal to 4.85 divided by 9.81, and it'll be falling for 0.5 seconds. So for 0.5 seconds, for half a second, that is the duration of the fall of the PS controller that Bambi knocked over. In summary, in conclusion, Bambi is a rat. Scientifically proven. There you go. Lies. Bambi was innocent. I don't know. I don't believe that. Now, we didn't look at the textbook. It's kind of nice that we just kind of wing a lot of these things, but maybe there's some like more challenging problems here. We can do a few interesting calculations, hopefully. There's no ghosts in space, Fizerp! Hi, Fizerp. Are there ghosts in space, though? There's Bambis in space, though. Clearly, there are Bambis in space. Okay. What are we going to do now? There's a few interesting problems, a little bit more challenging problems in the textbook, and I'm going to try and solve them. I didn't have my usual first year textbook that I usually teach from. I left it at work because obviously I teach everyone there. But look, there's some really nice challenging ones. We can do some fun stuff. You can calculate work and energy. You can. I'm not doing that today. Today is equations of motion in one dimension. So that's the topic for today's stream. But does the controller still work? If we introduced work and energy, we could determine just how much energy or how much... Okay, maybe momentum. Momentum would be a good one to calculate. The controller weighs whatever amount multiplied by the velocity at its impact. You can calculate its momentum then. You can determine if it withstands that impact. I don't know. We'd have to do a few experiments. Yeah, exactly. It is landing on, in our case, from the couch to the fluffy other part of the couch in this case. How long until we calculate how hard you have to throw it to kill someone? Yeah, that's interesting. We could calculate at what height does Bambi have to drop our PS controller on us to kill us. Because I swear, I think she's trying to murder us secretly. Not secretly, actually. She's not hiding it. She wants to murder us. To anyone coming in, Bambi is my bunny who free roams, runs around the house, causing chaos everywhere she goes. She sometimes comes into the stream. She's not here yet. She'll come here eventually to cause problems at some point. Okay, I'm going to take a quick break, a P and T. I'm just going to allow this message. There's nothing wrong with that message. Welcome in, Teresa. I won't be doing hydraulics today. Bambi from Carbon Oak. I'm from Ireland. If you want, there's more information on me on the About Me page if you want to check it out. If there's any questions there. Ooh. Bit of backstories, a bit of information, if you're interested. All right, we're going to go quickly to the bathroom. T and P. We're going to time out now. T and P. Grab yourself a cup of tea. I'm going to grab a cup of tea and a biscuit. And we'll continue with a few more challenging... Automod confusing. Could you do some exercise? I guess so, yeah. Exercises means something else in physics. Well, it could mean the same thing, to be fair. I'll see you guys in a bit. And basically what we have to do now is decipher these angles into X and Y components, horizontal and vertical. The description of the scene of The Lord of the Rings is basically Aragorn tossing Gimli across. We don't tell the elf. And there's a massive gap that he has to get across, but also the gap or the layer where the orcs are is slightly lower level. So there's a few approximations we have to make. Our goal here is to calculate how far across Gimli got yeeted, but also how long he was in the air. The first thing we estimate is the speed that Gimli is at, and we did a couple of things on my live Twitch stream to calculate this. Some of the things included calculating frames per second. Others did estimation of distance traveled per second, but basically we came up with 4 meters per second. The angle at which he was yeeted looked roughly 45-degree angle, and this is a chef's kiss of an angle to choose because this is the ideal angle to throw something usually. In this example, Gimli is being tossed at 4 meters per second and at an angle of 45 degrees. There is, however, also the issue that the level where Gimli is at and where the orcs are, there's a bit of a gap. And looking at the video over and over again, and again estimations and conversations via my Twitch chat, we confirmed and believe that it was roughly 1 Gimli. This is a standard unit of measurement and you cannot argue against me on this. 1 Gimli is roughly 1.37 meters, and so we estimate that the difference in height is about 1.37 meters in the vertical axis. As Gimli is being thrown, he follows a parabolic path, i.e. a curved path of motion. Basically, because we ignore air resistance, we say that the horizontal path remains constant. Nothing is changing the horizontal component of his speed at any point in time. We physicists love ignoring air resistance. But the y direction, the vertical component, changes every millisecond. At every point in time that Gimli is in the air, gravity is acting against Gimli, and at some point, at the highest peak, he wouldn't even be moving in the y direction. And then we'll begin to accelerate downwards. The vertical velocity changes at every moment in time. Here are some of the classical equations from kinematics that you would usually use to solve these problems. However, again, the problem here is linear motion. At the moment, we're at an angle and we're not exactly at linear motion, but we will decipher this. We have to break down Gimli's projectile motion into its x and y components. So, I hope you remember your trigonometry. If Gimli is being thrown at 4 meters per second at an angle of 45, we can depict the x and y component basically by using Pythagoras' theorem. Remembering your sine, cos, and tan rules, we can determine the speed of Gimli at the moment that he gets thrown in the x direction and the y direction. Remembering that opposite over hypotenuse is equal to sine 45, you can rearrange the equation to determine what the line of the opposite side is, i.e. his speed in the y direction. The answer is 2.83 meters per second in the y axis. We can do the exact same thing except using cosine rule, adjacent over hypotenuse is equal to cos 45, and determine as well that the answer is 2.83 meters per second. What is going on? Why is the answer the same? Is this a mistake? No, this is what 45-degree angle is all about. So if you ever see that 45-degree angle, know that your components are going to be the same in the y. This is great. We just determined at what speed Gimli is going up initially and at what speed he's going sideways initially as 2 separate components. The first part we're going to determine is how long was Gimli in the air? And we have 3 kinematic equations we talked about earlier. You could sit there and basically decipher, take off what information you have and what information you're looking for. And using this method, you can determine that you need the s is equal to ut plus a half of at squared. The x naught cancels off because that's the initial position and the initial position is 0. What we're doing here is we're substituting all the y components. How long Gimli is in the air is only dependent on the y vector, all the up arrows and all the down arrows, and that's what we're substituting here in this equation. We determined that roughly the height difference was 1.37 meters, 1 Gimli, but remember it has to be a negative. And also remember that when substituting for gravity, you have to make it minus 9.81 meters per second squared, because gravity is acting against us. We then get ourselves into a quadratic equation and we use the minus b formula. We know what the a component, b component, and c component is. I simplified the mathematics here and subbed in all the values, but we get 2 possible answers because there's a plus or a minus part of the equation. 2 answers result in 1.124 and the other one is minus 3.189. And I am ignoring the negative sign because, well, time doesn't move negatively, technically. That's another story for another time, why it can be negative. Alright, I'm back! Hello Adarsh, welcome in. I'm just gonna have a quick Raffaello. Don't judge me. It's technically not chocolate. So I'm not cheating on Lent. Hello. No, I don't think so. Terminal velocity is actually a lot harder than people give it credit for. I risked it for a biscuit, exactly, Frank. Oh yeah, this is good stuff. Oh, tea is so good. Tea. Oh. Technically correct is equal to best correct. Let's remove some of our stuff here and solve a couple of interesting problems. My tooth still hurts so badly. Oh, I'm gonna call all the dentists tomorrow. I really hope I find one dentist who is willing to take me. Hi, James. Hey. Oh, my demon core. Hi, Stephen. We've done a few problems, but you can come in and help us solve them for sure. It's okay to be late. Luckily, in university, we don't take attendance. Well, actually, it depends. Some universities do. A lot of my university classes did. But, yeah, I don't know. I feel a bit weird taking attendance. Most of the time, I don't. I do take attendance in labs because there's, like, this requirement that you have to attend labs. But, like, if a student doesn't show up to lectures, it's not my... What's the word? It's not my fault. It's not my problem. It's up to you. Life gives you lemons. It's your job to make lemonade out of it or something. Or something. Okay. Here we go. How long does it take an echo to return from a woman standing on a 300-meter cliff? Okay. So, a woman is standing on the edge of a cliff, like this. And she shouts, okay? And it's a 300-meter cliff. And the question is, what was the question? How long? How long does it take for her to hear back? This isn't, we don't even need to, use too many equations. The speed of sound in air, standard temperature and pressure. Speed of sound is 343 meters per second. Okay, that is the measurement of the speed of sound in air. I say standard temperature and pressure because if the temperature is higher, the particles have higher kinetic energy and they'll vibrate faster. If the pressure is really, really high, it means the molecules are more compact with one another, which means that they'll vibrate faster than via one another. They don't need to rely on traveling a little bit further. So the more dense your object is, the faster the sound is going to travel through it. So the speed of sound in water, for example, is like 1,400 meters per second. I'm not sure. But sound actually travels really, really, really fast in water in comparison to air. So it travels at 343 meters per second. So how long will it take the woman to hear the sound back, the echo back? Well, first of all, the speed of sound has to travel all the way down and then all the way back up. So it's actually traveling a total of 600 meters. Does that make sense? It travels all the way down to the cliff, 300 meters, and then it has to travel all the way back up 300 meters. 300 meters plus 300 meters, 600 meters. So, speed of sound in air is equal to the distance over time. We're looking for time. Let's rearrange our equation. Our distance is 600. Our speed of sound in air is 343. So it is just under 2 seconds. Get an exact answer. I built a sonar already. It's one of the labs I built. It was a big project. Is the speed of sound in air at standard temperature and pressure. So no, technically it's not universal. We will take a universal. It's kind of like saying the acceleration due to gravity on the surface of the Earth is 9.81. It's a universal, if I'm very pedantic with that statement. But generally speaking, anything can change it. The concentration of oxygen in the air could affect it because the molecule of oxygen versus nitrogen is slightly different. Obviously, it's probably so negligible we don't even have to worry about it. But it's going to be just under 2 seconds. It is 1.749 or 1.75 seconds. Okay, 1.75 seconds. Thank you, Zir. Good old tea. Oh, tea is so good. Okay, so we were able to solve that problem. That wasn't really equation Z of motion-y, but it was still a fun problem to solve. Why do you keep going supercritical? Jesus, the amount of radiation I've been exposed to today. The kinetic energy. I suppose the more loud you, the louder your sound is, the further it can travel because it has more energy, higher amplitude. But if, and eventually it will deteriorate. You lose energy. It's also, like pointed out, it's an inverse square law. So the further out it goes, the more it deteriorates over time. Oh, good tea. For every yeet, there's an equal but opposite yoink. I like that, Young. Welcome in, Bulbadin. All right, let's look at a more problematic problem, because that was a bit easy. Let's see. Is there anything fun? All these questions are boring. Is there any interesting problems? I thought there'd be something fun. It's all cars, sports car, bus, car, object, bus. Thought there'd be might something. Well, it's super stealthy, then it will travel for miles. Yeah, that's true. Technically, the echo could be an issue as well, for sure. Don't talk about it too much, but... Yeah, it's just all... Imagine a body, suppose a body's traveling at the speed, a car or airplane. Same problems all the time. There's nothing fun. Oh well. Okay. We'll just make up questions. It's fine. A seagull flies in the air. Oh god, how do I draw a seagull? Okay. So a seagull is flying in the air. There we go. Great drawing. And it is traveling at 20 meters per second. And it ends up crashing into a it's about to crash into a wall. To avoid this at the last second, at the very, very last second to avoid it. No, never mind. It doesn't stop in time. It crashes at when it was traveling at 5 meters per second. However, it did try to stop. It really did try to stop. It was trying to decelerate. Couldn't do it in time. And it was decelerating. Oh. If the distance is 5 meters when it sees the wall, and its deceleration was minus 0.3 meters per second, at what speed did it crash and almost die? Another problem we're going to do, the burb died. Yeah, the burb went splat. Another thing is going to happen, the rock falls. The rock falls, and it falls for a time of 30 seconds. How far up was the bird? It's a lot of problems. Hi, Grim. We need to get creative. We need to get creative. A lot of these I really think a lot of the questions in these exams and practice questions aren't interesting enough most of the time. So we're making things interesting. What did the bird have for breakfast? Oh, my nose is itchy. Okay, first problem. This is actually one separate story to the other. So we'll treat this story first. Our initial speed, u, is equal to 20 meters per second. Our acceleration is equal to minus 0.3 meters per second squared. And s is equal to 5 meters. What is the speed of the bird when it went splat? That's the question, basically. So let's look at our equations. We have u, a, and s, and we're looking for v. U, a, and s. The third equation is great. The moment of impact. What was the speed of the... Is it an African or a European seagull? Very important questions. Let's determine that in a second. We have to understand which one has a higher survival rate. So we'll use the equation v squared is equal to u squared plus 2as. We're going to rearrange the equation to find v on its own. V is equal to square root of u squared plus 2as. Okay, let's sub in all our numbers. V is equal to u, which is 20 to be squared, plus twice the acceleration, minus 0.3. Very important that it's a minus. And the distance it traveled is 5 meters. What is the final speed of the burb as it went splat? So grab your calculators. Square root, I'm going to put everything in brackets because I clearly made a mistake before. 20 to be squared minus 2 times 0.3. Oh no, it's not 0.3, it's 0.3. Multiply by 5, close brackets, everything under the square root. The speed of the bird, oh Jesus, was 19.9 meters per second. It really didn't slow down much at all. Poor bird. The speed of the beak was 0. Okay, that's fair. The speed of the beak was 0, while the butthole went at 20 meters per second. Yeah. So the speed of the seagull is 20 meters. Just to put it into perspective for us, 19.9 is just under 80 kilometers per hour, by the way. But just to get a more exact answer, it is 71.6 kilometers per hour. That is the flight of the bird as it crashed into the wall and died. And now I need to go watch the Holy Grail again. No wonder the bird went splat. Okay. The second part of the story was the bird was carrying a stone. And it dropped the stone. And the stone was falling for 30 seconds. How far up was the bird in the sky is the question. Part 2. Let's solve that. Okay, so t is equal to 30. Our initial speed, u, is equal to 0. Because I know that the bird is flying, right? But think from the perspective of the bird, that we're only thinking about perspective of the stone. All the stone feels is that suddenly it's falling downwards. From the moment the bird drops the stone is falling downwards in this trajectory. So its acceleration is 9.81 meters per second squared. And we're looking for s, the distance, how far down it was. Do we use this equation, or this equation? We're going to use this one. S is equal to ut plus a half at squared. And it's already perfectly arranged for us. And something very, very handy is u is equal to 0. Anything multiplied by 0 is just going to be 0. So s is equal to half the acceleration, 9.81, all multiplied by the time, 30 to be squared. Oh, back to bird artillery. I don't think a bird can travel at 80 kilometers per hour, by the way. You might want to check the physics on that one. I don't think it's possible, but maybe I'm wrong. 5 by 9.81 divided by 2. The distance was 4,401 more. It was 4 kilometers up. I don't think a bird... Oh, Jesus. This is... Okay, that bird was asking, what kind of wall is up that high? Jesus Christ on a cracker. You know, I always tell you to check stuff, you know? We won't be doing hydraulics today, Trezo. I have a theme for these lessons usually, and today's theme is equations of motion in one direction. I was, hello, Knack. There are a few birds that can travel that high. Okay. Time to do some science now. What are the birds that can travel at 80 kilometers per hour even? Just under 80 kilometers per hour. I suppose if there's wind assistance, maybe. Hi, bloatware. How fast? Fastest bird. Okay, fastest bird. Light speed. The peregrine falcon. Top speed is 390 kilometers per... Fuck off. 390 kilometers per hour. Okay. So it's a diving speed. There is apparently a ranking with birds, just looking on Wikipedia. There's the horizontal speed, and then there's the maximum speed, which is diving. So it's gravity assisted. But Jesus, that's still amazing. Holy shit. That's still pretty incredible. So horizontal speed, it can reach up to 110 kilometers per hour. That's the maximum recorded. The Saker Falcon has a maximum horizontal speed of 150 kilometers per hour. Holy shit, that's class. The Grey-headed Albatross has 127 kilometers per hour max speed. Cool. Damn. That's cool. Alright, alright. Never mind. This physics problem is clearly not that crazy then. But also still, poor bird. It definitely went splat. That bird absolutely did go splat. The poor creature. Poor creature. Fast and Furious next movie will include birds. It took one for science, yes. It took one for the team. It took one for the team. I'm just going to sit down for a little while. I'm sure we can solve another problem or two on this topic. I just need to sit down because I've been standing for the last 2 hours almost. What about a penguin? Do we want a penguin problem? We could come up with a penguin problem. Yeah, how fast does a penguin fly? Penguins are so cute though. Very, very cute creature. What happens if Bambi launched the controller at a 72 degrees above the horizontal? So that's not in one dimension anymore. That's 2 dimensions now. Projectile motion. We're cheating. But that could be something we could do for next stream. A different topic. Evolve this equations for motion science stream. The very looking pot of tea. Did I say pot? Sorry, cup. I got candles, 2 sets of candles, and I cleaned them afterwards, and they're cups. A chicken can fly over 500 kilometers per hour. Dead chickens are fired into jet engines using air cannons, commonly known as chicken guns, to stimulate bird strikes, for example, in aircraft certification tests. These tests, occurring at speeds that often exceeding 500 kilometers per hour, verify that engines can ingest birds without causing catastrophic failure. Fascinating. Okay. Fascinating. Next project. Yes, of course. Maybe we'll replace the bird. Exactly, Vilis. We'll replace the birds with lab rats in our tests. What do you think? I think we have an excess of lab rats. They're talking back a lot more lately these days. I don't know. I don't know. Hi, Quantum Cheeks. Welcome in. Welcome in. Sup, lads and lasses, welcome, welcome. I am a lab rat, hear me squeak. Why do you always assume initial displacement is 0? Well, it's arbitrary. It's like potential energy of any sorts. Potential energy. It's just where your story begins. You can define it at 0, axis, but then things can go into the negative axis depending on your story as well. It can go into minus state as well if needed. It's an arbitrary starting point, I would say. Only good lab rats avoid the cannon. There was an urban myth that a new guy testing the engines accidentally test. The B-2 bomber was the exact same side profile as the Falcon, because the aerodynamics are so perfect. The word peregrine, I hope I said it right, itself means wanderer in Anglo-Saxon. That's cool, Carl. Teresa, like I said, we're sticking to the topic of motion in one dimension today. We've done hydraulics sometimes before. We can redo it again sometime, but sticking under the rules of the stream that we stick to topics. Try to. I know it feels like we're ranting about... Oh, sorry. I know it feels like we're ranting about random topics, especially now. We're talking about burbs. Coffee mug. We actually talked about that, Carl. We talked about holes. That was a big topic, to understand what a mathematical expression of a whole was. Turns out it's quite controversial. All right. Will we do another problem, so? Oh, I know. This is a great problem. Quite different to what we were doing. Absolutely fantastic problem. What's printing, by the way? I'm actually printing a few gimmicks for my wedding. It's just some stuff. Silly things. Hi, Riders. Welcome in. Welcome in. How are you keeping? As an Irish person, can you do your best Scottish accent? Absolutely not. I will get cancelled on the spot. We don't need to do that anyway. You know, the Scots are very happy right now beating the Welsh yesterday. A very close call. We don't need to bash and insult the Scots today. No, these are just problems I'm making up, James. Most of these problems we're just making up. They're kind of fun. I'm very good, I'm very good. We're solving a few interesting problems of one motion. That's so nice. What an opportunity instead to insult the English. We don't need to do that. We showed them yesterday as well. The Irish, for once this year, showed up properly for a game. Do students get excited or sigh? That's actually funny, Sly. I do come up with fun questions. I always think, oh my god, I have a really great problem. There's a group of students who are into physics and they laugh, they chuckle, and they kind of are into it for sure. But I don't think anyone sighs or rolls their eyes at me. I never get bad. I get chuckles, but not negative stuff. A League of Legends problem? Never. Never. Have I? No, I've given them a Gimli problem, but so many students don't even know who Gimli is. Do you know that our generation doesn't even know... Our generation, sorry. The new generation don't even know who Gimli is. I know. I reference Predator, Alien, and Lord of the Rings. And majority of students do not know what that is anymore. John Bell was a great Irish physicist. Famous for his inequality. Wait, who's John?
One dwarf she won't ensnare so easily. I have the eyes of a hawk and the ears of a fox. Oh.
Since we were talking about penguins, I'm gonna draw a penguin. Oh god, this is so bad! Listen! It's fine. Fine. It's a penguin with a pebble. Anyways. The penguin throws a pebble into the air at an initial speed of 7.5 meters per second. It then crashes into the ground at a speed of 8.2 meters per second. Find the height of the penguin. Ooh, can I actually don't know if I can solve this. Maybe... Well... Okay, here's a statement then. Assume that when I launch the pebble It launches from the top of his head. So you know the way when you throw something up, it's actually in your hand for a while, you're applying a force, and then it goes into the air. So from the moment it gets let go, it's at the height of the penguin. The question is, can you find the height of the penguin? I don't know if we can do this. I just made this problem up. I don't know if it's solvable, but let's explore. I have a rough idea, but maybe I don't have enough information to solve it. Future, thank you so much for the bits. Oh. Away AliExpress. I ordered one thing. Won't leave me alone. Okay, so first start, there's two stories. There's the part where the pebble is being thrown in the air, and there's part of the pebble that is being dropped. Okay, so let's calculate the first part, throwing it in the air. So story one. Story one, the initial speed is 7.5 meters per second. The final speed is 0. And then gravity, or the acceleration due to gravity, is 9.81 meters per second squared. Minus, because it's decelerating. So traveling upwards is negative, traveling downwards is positive in this. Well, it doesn't matter. Anyways, gravity is acting downwards. So, what do we want to find out? Nothing. I actually don't think we need anything in story 2, to be honest. Technically, no, I do, yeah. So, what is the distance that the ball traveled from here further? Okay, so that's UVAS. That's V squared is equal to U squared plus 2AS. How is V final? Well, think about it. If I throw something like this, right? And I throw it all the way up and I stop the story. When it's right at the highest peak, the highest distance it falls to the top. For that moment, it's being thrown up, it's slowing down, and it stops for a microsecond. And then story 2 starts, where it falls. Does that make sense? So for the microsecond it's up there, it's going to be 0. But isn't t is equal to 0 when it's in its hand? Yes, it is. We don't need time. V squared is equal to U squared plus 2AS. We don't need the time. We can solve this without time. It would have the same speed if it came back in its hand at 7.5 meters per second. Okay? But it's going to fall all the way to the ground. The height of the penguin is this extra distance. So, V squared equal to U squared plus 2AS. We're looking for S. Let's rearrange the equation. That's V squared minus U squared all over 2A. Let's sub in our numbers. That's 0 squared minus 7.5 to be squared all over twice the acceleration due to gravity with a negative sign, 9.81. Now, it's okay that both of them are minuses. That's great. Minus over minus gives us a positive answer. Okay. We get an answer S of 2.68 meters. 2.6. Okay, so that's S, our displacement. So that's the height it flew up to the ground. Our next story, we leave that story behind. Let's just kind of accept that that's story 1. Then we go into story 2. That's a strong penguin. Hi, Gertrude. Welcome in. story 2 is going to fall all the way to the ground. So, our initial speed now is 0. Our final speed is 8.2. That might be very small. I'm going to change it to 8.8. I have a weird feeling there's going to be a bad answer, but look, we'll just keep going. 8.8 meters per second. And gravity, acceleration, is now 9.81 meters per second. And our question is, again, we're looking for s, the distance. We're going to use the same equation. That's v squared minus u squared over 2a is equal to s. V squared is 8.8 to be squared minus 0 all over twice the acceleration, twice 0.9.81. There. We'll just put that all in our calculator. (8.8 to be squared). Oh, sorry. 8.8 to be squared. Divided by 9.81 multiplied by 2. Go. 3.95 meters. Okay, so very interesting. So, from here to here is 2.68 meters. From here to here is 3.95 meters. The difference between them is the height of the burb, which is 3.95 minus the other height, 2.68. 2.68, which is 1 point. What is that? $37. 1.37. That's a really tall penguin. That's like really, really big. It's 1.27. Oh, sorry. 1.27 meters. An emperor, I guess so. How big are emperor penguins? Let's check this out. How tall are emperor? Oh, 1.1 to 1.3 meters. Oh, damn! Look at me making up a problem and getting an accurate answer. I'm amazing. I know. I'm wonderful. Stop, chat. Oh, stop with the compliments. We determined that the height of the penguin is 1.27 meters, which is quite a tall emperor penguin. And now he's smiling. He's happy. Oh my god, that's just so creepy. There we go. That was actually a fun problem. I'm glad. What's the mass of the object? We don't know. We don't need to know. Because we're not dealing with forces, we don't need to know the mass of the object. It's just equations of motion. Well, to be fair, Nak, I was just guessing roughly here. It was a rough estimate for sure. Oh my god, he does look like the Penguin Batman villain. Oh my god. Jesus. Now that you pointed it out, I think you're absolutely on the money. Colin Farrell. Must be recreational plutonium. Don't worry, we have plenty of that here. Alright, not bad. Not bad problem at all, if I do say so myself. It was a good problem. Oh, that's actually really complicated. There's a really cool phenomenon that happens. You have a really long chain and you throw the chain over and the momentum of the chain drags it, it actually does this like cool curve thing. A very cool phenomenon that happens with that. I don't know if you know what I'm referencing. Might be a very niche thing I'm commenting on. I'm pretty sure you're not supposed to pat a demon core like that. Listen, the demon core is my pet. I get to do whatever I want with it. Hi, Poopsie. As in Steve Mold. There we go. I don't know if that's actually its name. I know he named it, but is it actually named after him? Right. Not a problem. I could. Be nice to do one more. Oh, it is the official name. So we throw things, we drop things, we shoot things. Oh, yeah, bullet! We haven't done a bullet. There we go. Although gravity is acting on it. Usually we use bullets for projectile motion or momentum. Hi, Emilio. Hi, chap. Cannon shot is usually for projectile motion. Trying to avoid projectile motion, no angles, because that's 2 dimensions. We're doing everything in 1 if we can. Car stops. Oh, I know. We haven't really done this, but this is a typical thing that could be asked. Is I'll tell you a story. Here's a story. Have a lab rat. Okay. I won't finish the full drawing, but then we have a lab rat. And Tofu lets Bambi loose. And Bambi is about to eat the rat. The rat has to run away. So, Bambi's running after the rat. So, the rat initially does not notice Bambi for 2 seconds. The second it notices Bambi, it travels at 4 meters per second for 3 seconds. It looks back, sees that Bambi isn't there anymore, or that's very short. 6 seconds. It looks back, sees Bambi isn't there, and then stops. doing this problem right. Oh, I know what I'm doing wrong. So it travels for 4 meters for 6 seconds. It then stops for 2 seconds to look back. And then slowly continues on its way, just to make sure. Two meters or 4. The typical question that could be asked is to draw a time and distance graph or a time and velocity graph. In this case, I'm going to ask you guys, draw a time versus distance graph. So, let's plot our story. We have time here, and we have distance here in meters. So for 2 seconds, 1, 2, the rat doesn't do anything. Okay? So nothing happens. I'll take a blue graph line here like this. For 2 seconds, no distance changes. The next step is for the rat notices Bambi, starts to run immediately, and it travels 4 meters. Say 4 meters here for 6 seconds. So that'll be 8 seconds here. This is 4, 6, 8 seconds. Because it's 6 seconds of the total story, but it took 6 seconds to travel the 4 meters. So it's another additional 6 seconds. So up here, it traveled up to 4 meters. Slope of this would be the velocity of it moving. Then it stops to look back for 2 seconds. While it's looking back, it's not changing distance. It's a straight line. The distance isn't changing. It's staying at 4 meters. Then it travels for 2 meters for 14 seconds. So let's do 6 meters. A dash line there, so it's a bit more accurate. If you're doing this on graph paper, it'd be great. So at 14, it doesn't look like it, but this is supposed to be, if I did my rough maths right, this is supposed to be slightly slower than this one. It's supposed to be less steep of a graph than. So you could be asked, well, could you calculate the velocity of the rat in the first story, in the first part of the story, and the velocity of the second? You could do distance over time. Distance, 4 meters divided by seconds, 6 seconds. That's what? 4 meters divided by 6 seconds. Oh, that's just 0.67 meters per second. Another thing that you always were probably taught is rise over run. Do you remember that? That's your slope. So the rise is 4 divided by the run, which is 6, from 2 to 8, 6. 4 divided by 6, 6.67 meters per second squared. And then when the rat is running nonchalantly, it's 2 meters per, in 4 seconds. 2 divided by 4, 0.5 meters. And we have a little bit of a velocity time graph demonstration of linear motion. Another thing we could do is velocity versus time, and then the slope would be not distance traveled, not speed, but the acceleration is the next guy up. This is really nice visual representation as well for what calculus is. Like doing calculus, that's where calculus kind of clicked for me. Integration really clicked for me. Finding the area under the graph and all that was one of the aha moments. How much of Bambi's daily calorie intake is that rat responsible for? Yes, we should punish that rat for running away and making poor Bambi work for that. Poor Crather. The poor Crather. Sitting down now. My knees are sore. I did a small leg workout, but I don't know. Not as young as I used to be. Not as young as I used to be. Oh. Alright. And so we finish our topic of equations of motion in one dimension. A nice, thorough topic on it. Does anyone have any more questions, specifically about penguins? Or anything else in between? Any concerns? Was there something that was confusing? Otherwise, I'm very, very happy with our success of today's spur of the moment lesson with no lesson plan. I think we covered most things. Do you know penguins have knees? I did not know that. Can you pick up a penguin? As in, can I steal one? I don't think I can. How fast can your 3D printer move? Now we have killer bunnies. We're back to Monty Python. We always are. Burritos. Do penguins have knees? Yes, penguins absolutely have knees. Alright. I suppose it's so covered in... Yeah, okay. If you find a penguin, you can take them home. They're free. Noted. Noted. I'm sure if we be finding penguins in Ireland, we're going to have trouble. If a guard on top of a castle was to spit on me, how long would a spit take to land? Great question. It depends how tall the castle is. How tall is your castle? Freeze a jolly good fellow. Jesus, guys, how do you have so many penguin jokes ready? Why do you all have so many penguin jokes? What is going on? You're so sorted and ready for them. Hi, Silver. I think because Google exists. Okay, thank you, Hacks, for explaining Spooky's joke. It's okay, though. Spooky and I don't get each other's jokes most of the time, I think. I feel so bad, but yeah. We just flip our coin. Linux users? I don't use Linux, no. I'm familiar with it because of the Raspberry Pi, but yeah, I don't use it. Chat has been waiting for this day. Had a stack of penguin jokes ready to go. My gum is so sore. I really hope. Find a dentist tomorrow. I broke my tooth right here. The further one here. And it's just a really bad break. It's quite spiky. And it's just rubbing up my cheek the whole time. Honestly, I shouldn't be talking. I think talking is the problem. I should shut up right now. We shared them out, unfortunately. The unfunny ones went to Spooky. How do you know if someone is a desktop Linux user? Don't worry, they'll tell you. Isn't that the same joke about Apple? How would you know if someone is an Apple user? Don't worry, they'll tell you. Or is it the opposite? Android user. I don't know. I feel like that joke is used for anyone and everyone and anyone who you're the opposite to. Because they're scared of whales. Yeah, I know that seals hunt penguins. Good day. Hi, Kiro. Hope you guys are keeping well. It's a very recycled joke, yeah. It's just used against anyone who you just slightly despise. It also works for Warhammer friends. I actually went to a cool store in Dublin. It was like a gamer store. And like everything was Warhammer. I don't remember Warhammer being this big. There was a lot of D&D stuff, a lot of Warhammer, but also like it was overwhelmingly Warhammer now. How was that? Do people actually do that, Poopsie? That's crazy. Sorry about the truth. Look, Stephen, it's not your fault, of course. It's just a bit annoying. I need to relax talking. Although after 2 hours, I've only been talking for 2 hours and a bit. It's very sore after talking for so long. Damn. Neither, Sly. I'm not a Warhammer person at all. Since you're Irish, when was the last time you had a spice bag? Maybe a month ago. It's Lent now, so I can't have takeout. I'm trying to be good, giving up chocolates and takeout for Lent. Yeah, it's okay. We're finishing the teaching session, which is where I talk non-stop. So what we might do is we might transcend to play. No, that's a terrible word. That's not correct in this. Tofu, what the fuck? To Boy of War in a little while. I gave up Lent for Lent when I was a kid and never looked back. Yeah, look, I'm not religious. I'm as atheist as it gets. But it's good. It's a good disciplinary practice, you know, every now and then to fast. And you don't even have to fast properly, or like practicing discipline of something that you know is bad for you and giving it up for a short term to just, you know, it's an important skill, I think. It's a skill for sure, and I lack discipline. I'm really bad with that. I give in so easily. It's in my nature in so many other ways as well, but also in food, in drink, in anything. I'm just very bold and very naughty. Transition is probably a better word there. I sit on the fence just in case. Atheist, yeah. No, I think I'm more atheist than agnostic. I used to be a really aggressive atheist. Like, I was a nasty human being as a young adult and teenager. But it's not that I became agnostic over the years. It's more so I read more, I study more, I understand the role of religion a lot more in society and history. I have my passionate, angry takes of it, of course. But in a lot of historical contexts, it was a good structure. And I'm kind of more fallible, more relaxed about people practicing their own beliefs. I get a little bit more philosophical as to why I kind of accept it a bit more. You know, I reflect on a lot of things that happen in my life and what happens in others, and I'm a nobody amongst 8 billion people in this world who shouldn't be governing anyone's life. And yeah, just basically I am still very much a hardcore atheist personally, but I'm definitely not a hardcore atheist when it comes to society and like pushing things. That makes sense. That's a really sad statement, Poopsie. Yeah, like it is worrisome sometimes. No, but I used to be just a nasty, anti-religious person when I was younger. So I'm glad I kind of changed from that. But I think that's generally speaking, as you get older, you have very passionate views when you're young. But as you get older, that fire just burns out in you. I don't know if it's just life that happens. To be fair, not all sociopaths, just maybe some. Maybe some. Back from my dog walk. Once again, no rabbits were chased. Welcome back, Pega. We just finished all the maths. Now we're talking about religion somehow. I don't know how we ended up the topic, but yeah. It could be Typhoon, yeah. Lack of life experience. As you get older, you have more experience, you have more knowledge, more education, hopefully. I always try to advocate every day is a school day. Keep educating yourself every day. Learn something. Have a hobby that teaches you things, or you learn something passively. Never stop learning. Just get older and we learn a lot. And hopefully, yeah. More opportunities to get captured by an echo chamber. When you're young, is it? I suppose, yeah. I was in an echo chamber for a long time when I was young. I definitely, yeah, I didn't realize. I'm so glad I got out of it. I don't know. I've never really spoken about this before, let alone on stream on the internet. But I was in such a bad relationship and corner of the universe that in my young teens, for like 2 years or so, I was influenced by a really bad crowd of people. And I got out of that place for other reasons, but just to put in perspective, these were books and the group were religiously listening to, not religiously, but you know, religiously listening to people like Shapiro. And there was another guy who was really popular at the time when I was like 19. Forget his name. He was like, you know, on that side of the fence as well. I'm trying to remember that name. I think Google something. Oh, Milo was the other guy. I don't remember his surname. Milo maybe. No, Tate. Andrew Tate didn't exist back when I was young. Andrew Tate is a relatively new thing. Hi, Alex. A little bit late for class, but it's okay. There's a VOD. There'll be a VOD archive. I know which Milo. Yeah, that guy. So that was my circle of people I was around when I was very young, in my early teens, and late teens, sorry. And then I got out of that situation, and only now reflecting was like, I'd stayed there because I got out for other reasons. I don't know what could have happened to me. Yes, Seer. I think that's right. I could be wrong. But the surname looks familiar. On reflection, Jesus Christ, because I wasn't into it, if that makes sense. It was just around me. I wasn't, yeah. Sometimes. Kind of scary to think about it. Oh well. We're glad we're here today, where we are now. I'm very lucky to be where I am in life, honestly. I for the last few years, I've been very, very happy. I know I stress and I complain, and I'm always complaining that I'm always busy. But, generally speaking, when your life is like complaining about the dentist and complaining about Bambi ripping up the carpet and too many meetings, you know, that's actually a good life. That means that, you know, other bad stuff, possible worse stuff isn't happening at the moment, which is always good. Not sure I'm that grumpy. Still a lot of fascinating things exactly on that hole. I hope that passion never leaves me. I'm really worried that it will. In about 10 years time, I'm going to be a grumpy ass scientist who's going to be stuck in her ways and will be obnoxious and say, I know this already and this is very basic. How do you not know this already? If I one day become a lecturer like that, please just take me out. I become the thing I hate. That is the good life. Speaking of my little Bambi. Where is she? I had bought bananas today, and she hadn't had a banana in ages. I'd love to give her a banana. Will we bring Bambi over here and give her a banana? I think we should. Give her a banana today. Bambi! Bambi! Found a cutie patootie. I found a cutie patootie. Look at this cutie patootie. Ah. Hello, hello, hello. Banana? Smell it? Oh, she smells it. Oh, yeah. Oh, yes. Oh, okay. We're gonna catch this live on camera. Check this out, chat. See her butt? She twerks for banana. I don't know why, but only for banana she does. Well, some other fruit sometimes if they're very good. Do that. Do that butt twitch. She loves banana. It's her favorite thing in the world. Oh, you're getting all banana all over me. Oh, jeez. Slow down, slow down. Oh my god, the floof on you. So much floof. Look at all this floof. Look at all this floof. We'll twerk for food. Oh, you got banana all over me. Ugh, and so much fur. There we go. Isn't that right, Buns? Oh, yeah. We love banana. Love banana. Yeah? Anything you want to tell the chat? Yeah? Okay, you can whisper it. You can whisper in my ear. Yeah? Yeah? Okay. Yeah? 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 Okay, okay. Chat, she says you're not working hard enough. Uh-huh. Uh-huh. I should go dig deeper in the mines. Uh-huh. Uh-huh. And give more money and donations for treats. Mwah! Girl. Mwah.
Looks like meat's back on the menu, boys.
Thank you, Spooky, for 111 bits. Can you tell Bambi I'm poor? Bambi, no more treats. No. Oh. She definitely didn't launch a controller or a table. She absolutely does. Now she's cleaning herself. Bananas are very messy. Maybe you can see her in the corner there. She's cleaning herself. It's very sticky, so she gets all over herself. She needs to clean herself now. Yeah? Like bourgeois lifestyle. Stop. It's so funny. I used to spend a lot of money on Bambi. I don't anymore. But when I first got Bambi, I bought her a castle and pillows and beds and so many amazing things to spoil her with. Expensive toys, everything like that. That bitch destroys it or doesn't touch it. Either or. Oh, big stretch. Oh, big stretch. Her favorite thing in the world is cardboard boxes. Where are they? These cardboard boxes. So anytime we get a package, we just cut things out, and she loves the boxes. Boxes are the greatest thing. She's so cat-like in that way. Yeah, exactly. She's just basically a cat. She's a vegan. Is it vegan? Definitely vegetarian. Is she a vegan cat? I guess she's vegan. Yeah, now it's time for a stretch and nap. Exactly. So unfortunately, my tooth does hurt quite a lot. It's actually not my tooth, it's the gum, the cheek. So what I'm going to do is to shut up a little bit. We're going to not teach anymore, but we're just going to play some God of War, if that's okay with you guys. Which means I'll turn off my YouTube stream. If anyone from YouTube wants to watch the gameplay, you're more than welcome to come on, hop on over. But other than that, thank you so much for hanging out with us. Really appreciate it, and I'm glad I was able to help you guys with your homework. Hiccups. I also like cardboard.